All right, guys, today we're going to be talking about 8.3a, trig intro and trig ratios. We'll move this out of the way just a second. So the mission is I can identify the trigonometric functions and determine the ratios for each function. First, I want to go ahead and define trigonometry, and let's just really look at this and see what this really entails. So trigonometry. All right, so there's a couple of things we can see here. If you notice this first prefix right here, tri, tri, of course, means three. A tricycle has three wheels, but we also know that a triangle, right, starts with this word tri. So we see the word tri here, and then you see over here the word metry, okay? So when we hear the word metry, maybe we think about the metric system. So it is a unit of measure. Okay. So when we're talking about trigonometry, really, quite simply, it is just the study of triangle measurement. Okay. So that's basically all it is, but really it's kind of hinged on this one idea that you can take a right triangle with very minimal information and use some, and I'm going to shorten this to trig just to keep from having to say trigonometry all the time. You can use trig ratios to determine sides, even angles, with again very minimal information. So I want to paraphrase a little story because it'll take a long time, and I don't want to make this video super long. Um, but there was this particular little girl named Wilma who lived alone, kind of lived a real simple life. But one of the things she really liked to do was dance. Well, there was also a king, King Fred, who kind of lived a simple life as well. He didn't really get out and do much. So then he went out into the kingdom and he heard this music and he realized that this Wilma was dancing. And so he asked her, would she be willing to show him how to dance? Of course, they fall into love like any good love story. And so they end up getting married and they have this ritual every Friday night. They go dancing, right? But the problem is he's clumsy. The king's clumsy, and so every single time they dance, he ends up stepping on her toe. Well, what happens here is every Friday night they go dancing. Well, here she has this big toe that's been stomped all night dancing, and so Saturday morning she goes down to the pond and she soaks her toe in the pond, and so the story goes on, for years and years and years, and then finally, over the course of time, time changes the facts a little bit, and so instead of being called King Fred and Queen Wilma, they end up getting nicknames of King Klutz because he couldn't watch his own 2 feet, and she ends up getting called Queen Sokotoa because she soaked her toe in the pond every Saturday morning. You say, what in the world does that even mean? Well, I'm going to go ahead and write that out. Sokotoa. Okay, and this is a mnemonic that helps us to remember all of the trig ratios. So I'm going to skip over to another screen and a little notes page, and we're going to try to fill this guy out. Let me move myself back up out of the way. All right, so right here, what is trigonometry? Again, we've already said that is basically the study of triangle measurement. Okay, so then I'm gonna go ahead and skip down here to this particular part, and remember we just said her name, Queen Wilma, is Sokotoa. So Sochatoa. Okay, and each of those letters represent the trig functions. And you're going to get into a habit over the next few sections, especially. We're going to talk about how to find sides. We're going to talk about how to find angles. You're going to get into a habit of going ahead and writing this on your paper right off the bat, okay? Because it's going to help you to remember these ratios. So remember, this first letter is sine. It looks like sin. Math is not sin, though. So that stands for sine. The O and the H stand for opposite over hypotenuse. Now remember, these are ratios. So a ratio is really just a fraction, okay? So sine is opposite over hypotenuse. Cosine, which is the C here, stands for adjacent over hypotenuse. So I'm just going to abbreviate that ADJ and hypotenuse. And then tangent, which is the T here, stands for opposite over adjacent. So opposite over adjacent. And I'm gonna show you what that really means. Okay. So let's skip back up here to this triangle, and then we're gonna look at one example down here, and then I'll show you what your practice is gonna look like today. So you notice we've got this triangle. That's triangle A, B, C. Okay. And you notice the sides across from those are labeled as little c, little b, and little a. Okay. So the first thing it says is the ratio of the leg opposite the angle to the hypotenuse. So sine, remember from here, is opposite over hypotenuse. So let's think about what the hypotenuse is. So we're looking at sine of A, okay? Angle A is our focus right now. And what is the hypotenuse in this triangle? Well, the hypotenuse is right here, right? It is C. Now, the critical question is that you got to find the hypotenuse first, okay? Because that is going to be the bottom of my ratio. If you notice, sine is opposite over hypotenuse. So I'm going to go ahead and just do the hypotenuse as C, but I know that I got to have something on the top of my fraction. Well, which one is opposite? Which side is opposite? Is it B or is it A? So what I want you to think about is adjacent means right beside. So in other words, if you have angle A right here, you notice that I only have two sides that actually join angle A. That is the side that's got the hypotenuse, which we've already identified, and we've got this one that's connected that is actually adjacent. Okay, so B is actually adjacent to A, but the one that is across from A, right, is little a. And so what we would write here is we would write A over C would be, if I'm looking for sine of A, it is opposite over hypotenuse. So let's practice again with B. So now we're looking at, and I'm going to go ahead and erase this part so that we don't get confused. So now we're looking at sine of B, which means that my focus is angle B. So sine is opposite over hypotenuse. Remember, I already kind of know what the hypotenuse is. That's C. And so the top of my fraction needs to be the side that is opposite. So the side that is opposite would, in fact, be little b. Pretty simple. Now let's look at cosine real quick. So again, for cosine of A, my focus is on A, so I'm going to think about it. But remember, my trig ratio for cosine is adjacent over hypotenuse. So this time it's going to be a little bit different. I'm still using hypotenuse, so I know that my hypotenuse is C. And then what is adjacent to A? Now remember, it's not across from, it's not opposite, but it's the one that is adjoining other than the hypotenuse. Well, the side that is adjoining is actually B, so my ratio would be B over C, okay? Just for the sake of time, I'm going to go down here to tangent, and then we're going to look at a live problem, and I think it'll make a whole lot more sense. So let's go ahead and erase this out. And for tangent of A, again, my focus is, in fact, on A, okay? But tangent is opposite over adjacent. So I'm not really even using the hypotenuse at all when I'm talking about tangent, but it is opposite over adjacent. So what is the angle that is opposite angle A? Well, again, think across from. So across from angle A is little a, opposite over adjacent, and what angle is, or what side is adjacent to angle A? Well, it's right here, right? It's connected to it. So A over B would be our ratio. Now let's look at this with some live numbers because I think it'll make a little more sense. So we're looking at this problem number 1 right here, and it's giving me this triangle, and it's going ahead and giving me the sides. You notice that? It's going ahead and giving me the sides that are here. So all I really have to do is just do the ratios, okay? So sine of A, right, is right here. This is angle A. And remember, sine is opposite over hypotenuse. So what is the side that's opposite A? Well, it would be right here. So it would be 5 over the hypotenuse, which in this case is 13. And that's all you have to do, literally, is just write the ratio. Same thing for cosine of A. So for cosine of A, our focus is on A, so we'll go ahead and erase that out. Cosine of A, remember, is adjacent over hypotenuse. So what side? We know the hypotenuse is 13. Let's go ahead and write that down. But what side is opposite? Or I'm sorry, adjacent? Well, you notice that this 12 is connected, right? Connected. So this 12 would be our adjacent. And then last but not least, we're talking about tangent of A. So tangent of A would be opposite over hypotenuse. And again, that's why these ratios are so important, because it tells you what to do. So tangent is opposite, which would be 5, over adjacent, which would be 12. Remember, the hypotenuse is not part of the equation when it comes to tangent, okay? So that's literally all you have to do for these problems. Actually, I'm going to go ahead and just skip over to the work that you're going to have today, because my only mission for you today is that you, number one, kind of get the ratios in your head, the SOHCAHTOA in your head, and these ratios, and that you just be able to write the ratios. And then tomorrow we'll move on to finding sides and that kind of stuff. So here we go. Let me see if I can make this a little larger. It'll help us out, I think. All right. So for this particular one, again, we're looking at tangent of C, number one. So the first thing I would do is I would go ahead and circle the angle that I'm really thinking about. Okay. So then one of the other things I'm going to do, the first thing on my paper, is right up here at the top, I'm going to go ahead and put SOHCAHTOA. Okay. And you should have did better than me. You should have left yourself a little bit of room so that you can go ahead and write them out. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Again, this just kind of helps me to keep it in my memory as to what's what. And tangent equals opposite over adjacent. Okay, so those are my trig ratios, and that's going to help me when I start working out these problems. So now I've got tangent of C, which again, my ratio is right here. It's opposite over adjacent. So what is the side that is opposite this angle C? Well, again, think straight across from, and that side would be 21. Okay. Now, what is the adjacent? Well, the adjacent, remember, it cannot be the hypotenuse. So maybe the first thing you ought to do is go ahead and define your hypotenuse, which again is across from the right angle, and it's always the longest side. So this cannot be adjacent right here. This one is, in fact, the hypotenuse. So the only one that's left, I've already chosen 21 as the opposite. The only one that could be adjacent would be 28 right here. Now, the one thing that I am going to ask you to do is you're going to have to simplify, okay? So 21 divided by 28, what number are going to both? 7, right? 7 will go into 21 3 times, and 7 will go into 28 4 times. So you are going to need to simplify these fractions, but literally this is your answer, okay? It's just going to be a simplified fraction is going to be your answer for all of these. And so again, hopefully this has been helpful to you. If you need any help, obviously reach out to me today, and I'd be glad to try to help you with this. But as long as you have these ratios right here, I think it's going to be pretty simple for you to figure it out. Opposite, adjacent, hypotenuse. That's the only three things that you're really looking for in any right triangle. So see you tomorrow, hopefully, and have a good day today.